two hearts that were kind of cut different ways, but we're going to use both of them to look at features of it. So when you look at this thing, it's easy to tell top from bottom, right? Because you have the base and you have the apex at the bottom. The hard part is telling how does it go this way now, right? So what you want to look for are two major blood vessels that run down. One's in the front and one's in the back of the heart. Okay? The one that's supposed to be on the anterior side of the heart is this one right here that comes more at a diagonal angle. Okay? The one that's on the posterior side of the heart is a little bit more vertical. Okay? So this is a major one, a big major one. You see that, you know that you're looking at it like this orientation in the body right here. So this is right and left. So externally, you should be able to tell right auricle and left auricle. Okay? What are the names of the chambers inside of these? The atria, right? Right atrium is inside, left atrium is inside of here. Okay, so let's follow the flow of blood through the heart. Let's start with, let's look at this one. The superior and the inferior vena cava were cut way too close to this thing. You can see where they would have come in right there. There's a big hole right there. So that's where they would have connected and come into the right atrium right there. And I've cut it through the atrium, through the auricle, so that you can see inside of the atrium. Okay. Do you guys see those muscles, those strings in there? Somebody thought they looked like teeth of a comb. So they called it pectinate muscle, which is what pectinate means, like these parallel lines of ridges of muscle. Okay? So here we are in the right atrium. Where's blood going to go to next?
Right ventricle.
The right ventricle. So it's going to come down into this chamber down here. So I'm going to open this up. Remember, this is the orientation, so you're looking at it from posterior view here. We can see that to get down into there, we're going to pass by this valve, these flaps right there. Make sure you guys can see those. You guys see those flaps? There's one of them right there where my pinky is. Okay? So there are three of these flaps. We have 1, 2, and then I cut through one of them right there. There's 3 of them. So this is the tricuspid valve on the right-hand side. And they're attached by those strings, which we call chordae tendineae. Okay, those are your heartstrings, right? Okay, and then those heartstrings are attached to the walls of the ventricle down here via these things called, I'll show them to you on this one right here, papillary muscles. So if we look at this one right here, here are the chordae tendineae, right? Here's papillary muscles attached to it, okay? Papilla means, in anatomy, it looks like a nipple. That's really what it means. So, if that helps you remember it, I hope that works for you, okay? So those are papillary muscles. But let's go back to the right ventricle here. So here we are in the right ventricle. Where are we going to go to next? You can cheat.
Pulmonary.
Right, we're going to go up and out the pulmonary trunk. So I've cut it along here as if we're mirroring the flow of blood through here. So the ventricle contracts. We're going to head up and out. And do you see this blood vessel that I've slit in half right here? This whole thing? That is going to be the pulmonary trunk, which will eventually split and give rise to those pulmonary arteries. So far, everything is still blue, okay, on this side. If we look, and what I've done is I've cut this open so that we can look inside, right where it changes from ventricle to the pulmonary trunk. Do you guys see these little bags right there? Those are the pulmonary semilunar valves. They look like little half moons. They look like little pockets. Okay, so those little flaps right there where my pinky's in is the pulmonary semilunar valves. Okay, then out and then to the lungs. When we come back, we're going to come back from the lungs into the left atrium, right? So again, here's our situation right there. I'm going to open it from the back again and let you guys see inside of the left atrium. So you guys can see that? Yeah? Okay. Same sort of situation going on here where we have this valve now, right? This one this time on the left side only has 2 cusps. So what should we call? That would be the bicuspid. Also called the mitral valve because Mitral is the name of the Pope's hat. You guys know the pointy hat that he wears? It has like a front and a back to it. Somebody thought it looked like the two cusps of the mitral, so they called it the mitral valve. All right. Again, attached to papillary muscle. Here's a good papillary muscle via these chordae tendineae, those heartstrings. Okay. If we look inside, lining the wall of the ventricle, we see that trabeculae carnii, that literally translates to branching meat. Okay. If we look at it up from the other side, if we look at the right, we also have it in there. Let me open it this way. Do you guys see all that branching meat in the right ventricle up here? Mm-hmm. Trabeculae carnii. Okay? So those line the rest of the walls of both ventricles. Now, most of the hearts are going to be cut open like this, okay? Straight in half. If we look at it this way, well, let's situate ourselves. So I want you guys to tell me, I'm going to rotate this around. I want you to tell me when it's oriented properly according to my body, okay? So tell me when to stop. Right, you guys saw that huge blood vessel running at an angle there. Okay, so here we are like this. I'm going to flap this open. And now you can't tell right from left, right? Because you can't see the blood vessels on top. So how are you going to do it from an internal view? What do you notice it might be vastly different between the right side and the left side? So here's the right ventricle, here's the left ventricle. Here's the right atrium, and up here is the left atrium. How would you tell?
The left is larger.
It could be, well, definitely the thickness of the wall is larger. Okay, so look at how thin that ventricle wall is on the right. Look how thick.
There's like a corner and it's thicker right there.
Yeah, this right here is called the interventricular septum, the border between the ventricles. Okay, and why do you think one side would have a thinner wall and the other side would have a thicker wall? Think about where they might be pumping blood to. Where does the right side pump to? The lungs, which are right next door. So don't need a lot of oomph for that necessarily. What about the left side? To the body. So you need a lot stronger contraction ability to get it all the way out to the rest of the body. So that's a good way to tell when things are open between right and left. Okay? So let's continue on our quest through the heart. So we've opened this up. We've gone from the left atrium down to the left ventricle. Where do we go next?
Pulmonary trunk.
Not the pulmonary trunk. Remember, this is going to pump to the body, right? The left side. So we're going to come out the...
Left atrium?
We went from left atrium down to the left ventricle. And then out the aorta, exactly. And you guys remember the aorta then branches into every single organ in your body, right? So let's see if we can do that. It's kind of hard to see where I'm poking this right now. What I'm going to do is I'm going to go in, find where I know the secret little hiding passageway is. Let me see. Okay, so here, if I'm a molecule of blood, pretend that the probe is the passageway that it's taking. So I am actually, let's see where it comes out. Do you guys see where the probe's coming out? Mm-hmm. So I went down here from the left ventricle, up and out to the aorta. This whole structure right here, hiding right behind the pulmonary trunk. This is the aorta coming out and around. So here, this one right here was one of those, like the brachiocephalic trunk and the common carotid. And this is the major part of the aorta that was coming out and around. So you can see that that's a huge vessel right there. Okay, so that's the aorta. So, in order to see this, I'm going to open this up a little bit better. Maybe you guys can see where the probe is going. Okay, you can actually see the beginning of the aorta right there. And I've cut it, I've slid it open the same way I slit this one open. Okay, so I'm going to pull out the probe so I don't break anything. If you look right where the aorta is starting, you should see some little pockets in there again. These are the aortic semilunar valves. If you can't see those, let me know. But do you see the little pockets in that? Can you see them? You guys can all see them? Just like the pulmonary semilunar valves, right? Okay? All right. Then out the aorta. The other thing that I wanted to show you is, we're only going to ask it to you on the model, is that fossa ovalis. But if you're adventurous, you can stick one finger into the right atrium, your thumb into the left atrium, okay, and try to touch your fingers in between. You can actually feel a little indentation. There's a spot right there where your fingers are almost touching each other. That indentation is the fossa ovalis, and the function of that is when you are in your mother's womb, you don't need your lungs yet, right? Because your mother's providing your oxygen for you. So what happens is we need to bypass this whole right ventricle. We don't want it to pump blood out to the lungs because it doesn't need to go to the lungs to pick up oxygen. So what happens is blood is coming back from your body and going into the right atrium. We take a secret passageway, boom, straight across into the left atrium, totally bypassing that pulmonary circuit. From there, it goes on the regular route down to the ventricle and then out to the body. So there used to be a hole there. Once you're born, that hole closes and gets kind of covered over with connective tissue, but you can still feel that indentation in there. And it becomes, when you're in the mother, it's called the foramen ovale, because it's actually a whole foramen. Remember that from bone days? Mm-hmm. Now that it's closed, once you're born, it's the fossa ovale, because now it's just an indentation. Again, just to bypass that pulmonary circuit, because it's not in use yet. Okay? So, feel free to look at any of the hearts. They're in a